All right, we'll go ahead and get started. Again, once again, my name is Shei Shimbore. I am signed in here as the organizer for the webinar, but the webinar is going to be presented by John. And John has, several decades, as I mentioned, in plastics manufacturing experience, and he's going to be talking about the Creo mold design extension. And so, John, you can go ahead and take it away.
Okay, good morning, everyone, and thanks for joining us. Thank you, Shei. And so today we're going to be presenting Creo mold design extension utilizing Creo 6.0. And let's see. So again, just a quick objective for today: review and demonstrate Creo 6 or Creo 6.0 mold design extension. Do an introduction of boundary systems. Myself. And then we're going to basically just jump into a Creo mold design demonstration. We will follow that up then with some questions and answers. For the meeting purposes, everybody attending, you're on mute, but if you have any questions, feel free to type them into the GoToMeeting to the organizer and that. And we will do our best at the end of this meeting to answer and address whatever questions and anything we can't answer today. We'd love an opportunity to reach out to you and set something up outside of this meeting and address those questions and or do additional demonstrations. So with that said, let's move into the introduction to boundary systems. Oh, sorry, myself. So my name is John Hughes. I'm a technical specialist with boundary systems. Like Shei said, I've been working for 20 plus years, primarily in the plastics industry. So designing plastic parts and then utilizing all of the tools and the software, especially associated with PTC Creo products, as far as on the CAD, the parametric for designing the parts, and utilizing several of the other extensions, for molding simulation and FEA, and now a lot with the mold design extension. So enough about myself, about boundary systems. We are a technology leader. We are located in the Cleveland, Ohio area. We are a partner to PTC, e.t.c, and other technology companies. We are in the top 16 fastest growing private companies in the greater Cleveland area. And we are part of the PDSVISION group of global companies. And here are some of the areas where we are located out throughout Europe, Asia, and Africa, South Africa. Some of our capabilities include product lifecycle management, data management, CAD design and consulting, simulation, and various product development. So again, we have industry awards, Inc. 5000, Weatherhead 100. We are a PTC Platinum partner, a Windchill certified implementer, a PTC preferred service provider, and authorized and certified training partners in Creo, Windchill, MathCAD, and Arbortex, as well as some other software partners. So yes, our primary partnership is with PTC. We have our channel advantage, service advantage, and then we have other softwares that we partner with to assist with various things. And talking about plastics, the Moldex 3D is a molding simulation software that we also partner with. Utilize a very powerful tool used within design and development for plastic injection molding parts and components. e.t.c, Keyshot, ZWCAD, and other software partners that we support. So I guess moving into the Creo mold design extension. So the Creo mold design extension, that's an easy and seamless tool embedded within PTC Creo that I guess one of the powerful tools it's definitely for laying out some tooling layouts and evaluating and establishing and setting up party lines, lifters, slides, shutoffs. So it's just an embedded tool, especially if your native part is a Creo CAD file. You're working within that interface directly, and then everything is just integrated. Your components are designed and developed, and your tooling can be designed in Creo, or if you're at least trying to get some information out to a tooling shop for some quotes, whether it's preliminary or early on, you can get that information so that everybody is working off of the same data set. So with that said, we will go into the product demonstration. So just close this out for now. So you saw the part that I've got there. We're working on an appliance console. And that's something I picked because that's something I've worked on a lot for the last couple of decades. So we launch our Creo 6. Of course, we set our working directory to the file that we want. So I've got this one part, so I'm keeping everything streamlined. I've got the one part we're looking at for a reference model. We open up that model, pretty basic and simple console design, again, because this is a webinar and we want to keep this kind of down to the time limit and allow opportunity if we need to go into other areas later. But for now, we've opened up our part. It's as simple as going into the applications. And under these applications, we've got all these other extensions that go along or that can be added and embedded within the Creo. We're going to look at the mold and cast extension. So we select the mold and cast extension. One of the first things you want to do, whether you're the designer designing the part at the beginning, you're the analyst evaluating to make recommendations for injection molding, or you're the tool designer and you're just trying to get this information, get a preliminary tool design laid out and set for quoting purposes and or evaluation. So we opened up our part, we launched the application, the mold and cast, and one of the first things you want to do is to validate that is your part manufacturable. So we want to kind of do a draft check. You can do that in the Creo parametric, but it's nice and seamless in the Creo mold design extension. We select the draft. We can select the console or the solid geometry. We want to select the direction, same as within Creo parametric. And we kind of know that the parting line is going to be horizontal plane. Here again, this defaulted to a 1/2 degree draft. We could have changed that draft angle. And we're checking our part. And we're looking to see that, yes, we've got our cavity side. Everything appears to be drafted properly. Our core side, everything is drafted properly. We have some geometry on the front, just a basic logo to simulate a slide action. So, everything looks good at this point. We can select OK. So here we actually then go, we're going to close the part. And to start the mold design process, we go into New and Manufacturing, Mold and Cavity. So here's where we can actually specify the name. We're just going to call this console mold, whatever name that your company wants is fine. We're going to uncheck the use default template, select OK. Now then this allows us to whether or not we want to work in English or metric. So the part was designed in English, we're going to leave it in English. We're going to open up the parts. Actually, probably best to make sure that your datum planes coordinate system are displayed. Now here's something too, within the mold design extension, we notice our X, Y, and Z coordinate. Now this is designed for the layout primarily for when your injection mold is put in the press. So it's in press position, which typically positive Z is your cavity or your parting line to the right, pointing in the direction of your screw barrel and nozzle. So this will go back. I'll show you in the part. It's probably a good practice to actually make sure you have a coordinate system in your model that you're going to be using that represents the part in mold position. Okay, so the next thing we want to do here though is we want to set the configuration editor options. We want to actually set the tolerance to enable absolute. I can't spell. We want to enable absolute accuracy. We want to set that to yes. Select OK. OK. But we don't want to save this necessarily to our configuration settings, so we can hit the OK, OK, and no. Now, so we've started our manufacturing mold cavity. We've set the accuracy. The first and next step is to select a reference model. So we're going to locate a reference model. This is pretty simple. I've only got one part in here to start, so it's very easy on this point. We're going to open that up. Now there's a couple different options here. I'm going to select the same model. What this does is when you select the same model, means that it's linked parametrically back to the original model. So if you make any changes into the original CAD model, into the PRT file, it'll update within the tooling. So whether you're suppressing geometry or restoring things, so you can determine what you want to do. In this case, we're going to use same model. Select OK. Now we can preview it. So here was the question. This is what came up. So I did the preview. It used the default coordinate system in the part. So the orientation is not set in tool position. So what we want to do here is we want to select the reference model origin. We have the window that pops up, and now we have the option of selecting the appropriate coordinate system we want. Now in this case, I've got a couple coordinate systems done because we did some preliminary work on here to say if we were going to build a tool on this for injection molding, and we wanted to evaluate the molding process. I've got a coordinate system that is set near the back for the runner system that I would want to evaluate. We can turn on the coordinate systems. Okay, I've selected the coordinate system I wanted. Preview, we can actually see that the orientation changes, and now we have it oriented in the proper pull direction for your cavity side, in your positive Z, and your core side in your negative Z. Now we have some other options that show up here, and this is just for the demonstration purposes, but you can actually, it's defaulted to a single cavity layout. We can actually go through the process of changing it to circular or rectangular. And again, just hit the preview. So if you were wanted to evaluate like a 2-cavity or multi-cavity, of course, this is a little bit larger part. Probably a 2-cavity is going to be the limits that you're going to do. But we can visually see that, and you can actually change to look at different options. So again, depending on the size of your part, you can play around with your cavity layout. You can switch them around. So kind of nice, neat functionality within the mold design extension. But we're going to stick with a single cavity tool because the importance of this is the ease of developing your parting lines and your shutoffs is what we want to demonstrate primarily. So we're going to select OK. Confirm setting absolute accuracy, yes. Then return. Now, the next step, so we've gone kind of with your ribbon here, everything moves kind of left to right. We've selected reference model. Next step is to do our workpiece. So workpiece is going to represent the core and cavity blocks, the geometry around there that we want to separate. First thing to do is mold origin is to select the coordinate system for this mold assembly. So I typed a uniform offset around the part, so it's going to basically go from the geometry of 2 inches. I mean, you can modify that accordingly. This can be done in English or metric. Again, I'm working in English for this demonstration. So again, if you know what your overall tool core and cavity blocks, the thicknesses are going to be, you can specify that here, but it's not necessarily as critical at this point. So we've got a 2-inch clearance around the part, uniform offset. We hit the preview. This is fine for this purposes. We're going to select OK. So we have our part in here. We have a reference part. We have our mold workpiece. Next step is to develop the silhouette curves or the lines to establish our parting lines and our shutoffs. So I selected the silhouette curves. Silhouette curve. Now it automatically selects, it was automatic, so it selects the part in the geometry. Now one of the things you have to do here, because this isn't always the easiest. In fact, I'm sorry, I'm going to go back because I want to show something with that. We selected the same part. So I want to go back into the part. And I mentioned before that we actually we did some analysis for gating. So we have this runner and gate portion that I want to have in here because it's not necessarily a traditional gate. So I've got to step that parting line. So as you can see, I resumed that into the model. And it resumed it in and updated in the geometry here. We did the workpiece. We're going to go silhouette curve, automatic. Now, what it does is it does its best to create datum curves along all kind of shutoff and geometry, whether it's going to be core cavity, a shutoff, perhaps a lifter, or a slide. So what you have to do though here is select the loop sections, and I know that this geometry is going to be a little bit troublesome, so I want to kind of unselect that. So I'm going to select these and tell it to exclude. And apart from that, everything looks okay. Now, depending on the parts you have, you might have to go through a little bit more work on this, depending on the complexity and if there's any import issues, if it's from another software. But very powerful tool here. And I like the datum curves that I have for the loop selection. So I have my silhouette curves. Next step is, tell you what, let's display. I can work in shade, but let's turn that workpiece off and let's actually turn off some of our other datum tags. Okay, so we're going to go back into the mold. Oh, so you can see you can jump back and forth into your parametric and into your mold. So parting surface. We're going to do a skirt surface. We've got different options here. This is to help you develop other areas, but for this part, we want to develop the parting line. So skirt surface. Selecting is easy as selecting. So I selected the silhouette curves. Next is to define the extensions. So let me step back on that. So we selected the silhouette curve. Now the extensions defining, it shows all the curves that were selected, but we want to do extension direction. So we can check and see the direction that these curves are pointing. And it's important to make sure that, like in this corner, it has an option of pointing 2 directions. So what we're going to do is add. We want to make sure everything on this front face is pointing to this front plane on our workpiece. So the direction that it's going to project that surface is okay. And we have a few more in the back, so we want to fix that as well. You don't necessarily have to select all of these, but it doesn't hurt. And then we're going to make the direction normal to this back plane. Okay. Okay. And we select the preview. And as you can see, that at least our parting surface shutoff has been developed for the core and cavity split. It's closed up all the loop shutoffs for all of the hole features that we have here. And as simple as selecting OK. Now, what we could have done here is I could have specified a name, but now just to exit out of this, we want to check and accept. So we went through the process, reference part, silhouette curve, parting surfaces. Now the next step again, moving left to right. Oh, nope, actually, we need to go back in and I need to do a mold volume. Sorry, mold component. Create mold component. Oh, sorry, yes, mold volume. We forgot to create the slider for this graphics. So did the mold volume, defaults the slider, extrude. So again, just takes you back to the interface of your Creo parametric. I'm selecting this front datum plane. Now again, this is just for demonstration purposes, but we're going to have a slide that comes in and forms this logo that we've got on this front face. So a couple options here, offset, select loop, we want this surface, accept, we're going to offset that 0.1. Delete, delete. So we created a sketch to represent our slide action. Select OK. Spin it, rotate. We want the direction to go into the what's going to be the cavity side. Our depth, we're going to go up to this front plane. Select OK. So now we just got this big block in here, but next step is simple. So we created that extrusion and we want to trim it to the reference part. And as you can see through our shaded, that it's actually removed the geometry simply and seamlessly for us and developed this slide. So okay, I'm going to turn that shaded back on. Go back into the mold. So we've created our parting surface and our mold volume for the slide. Next part is to do the reference cutout. So again, it does it pretty much automatic. It selects your workpiece and your part reference. Select OK. So we have our reference cutout. We can turn off some of this other geometry here. I'll leave that. Now the next step is simply to go in mold components. Sorry, mold volume. We want to do volume splits. So we're taking this solid geometry, we're going to split it about the parting line that we developed and the slide action. I'm going to select the workpiece. Select our slide. And of course, should not have hit that. Mold volume, volume split. Select the workpiece, query select. So first step was the workpiece, and the second step was select the parting surface and the slide action. If we want to here, nope. Okay, so I guess that's good. Not the greatest demo because we have a little error. So we're going to hit cancel here because this happens on occasion. Reference mold, volume split. We're going to do this the old-fashioned way. Okay, so we've gone and split that in two parts. So we have a, could have renamed this to core. Cavity. Now, what we can do here is, so we've got just for display. So we can turn off and show we've got our core side. And as you can see, we've got all of the shutoffs and all the surfaces developed. And that took a little bit longer with some of the user interface errors there, but did that pretty seamlessly and quick. So we have that one part. So we have that slide action. So what we want to do is in the part, so we've split all of our geometry, but these are all just volumes. So they're surfaces, it's not solid geometry yet. So what we can do here is the next step, again, moving left to right, is to create cavity inserts. And it shows us the volumes that we've created. So we've got a mold volume 1, which was that slide, volume 1 and volume 2, the core and cavity. We select OK. As we can see now, it generates the part files required for this. So we're going to turn these other unnecessary geometry off. So this should be named, we can rename this. Okay. Well, I skipped the naming, but we can rename that and assign that. So we've got this volume for the core side. Actually, and I want to activate the cavity side. And what I want to do here is we created that slide and there was a slight issue with it subtracting the material, but it's very simple resolution. We can do a extrude. Select this front face. So I changed and set that cavity as active. Loop. Okay, we want to change directions, remove surface, and we can just do a through all or a specific depth. And now we actually have our slide action with the geometry. Now this can be used, of course, to create the slide or if we had a lifter requirement, we could have done that as well. This can then be used to design and build electrodes if for certain geometry that can't be machined. Okay, so again, we've got this mold console assembly. We've got the reference geometry that was used to build it, but we've now extracted into the three components in this case, basically a core and cavity and a slide, and then this geometry can be used to develop if we're going to do a multi-cavity tool, but to machine, figure out the mold base size, and that kind of goes more into the mold layout. Next step, if we wanted to see it, well, within here too, it also has this other functionality. So you can create molding, you can generate your water lines, you can put in your runner system. So you can actually do more stuff in here. Honestly, it's something that is probably more done in the mold layout, not necessarily in this area, because you still have to go through, there's other areas and it just would seem streamlined, because if you're even doing your ejector pins, you can put those ejector pin locations in here, but when you go and build the whole entire mold, you have to do that through the rest of the geometry, and all that other geometry is not in here. So again, this is a great and powerful tool for developing parting lines and shutoffs relatively quickly. Next thing is we can do mold opening, define steps, define move. We're going to select the slide, a direction to move it, and we're going to move that out 15. Done. Oh, because I don't have it shown. So again, kind of quick. What was that? 20 minutes to split out core cavity and slide action. So along with that said, going to move on to another quick little part. Again, it's a relatively simple part. Of course, we want to save this. So as we can see here, when we had started with that part, I only had the one reference part, and now we have the mold volume for the core cavity, which if we wanted to open, now it pulled the colors that it had on the parts. Obviously, you can go and change the display the way you want these on these parts. And again, then this information can be shared with whoever in the process of building and manufacturing those tools, or even for quoting purposes, especially if you're a molder appliance industry and you're sending this out to at least 3 shops, and you want to make sure everybody's quoting roughly the same thing. And especially if you've gone through the process to design in your melt delivery system and evaluate that through molding simulation analysis software. So let's minimize this. I have another part. Again, so we've got this little housing, and what I want to demonstrate here is the ease and ability of designing shutoffs. So we've got this bypass window. So again, going to applications, mold and cast, and close this. New, manufacturing. Zero, 2. Again, whatever your naming scheme you want, we can, this I know is done in metric, so use default template, uncheck that. This is in metric. File options. Add. Enable absolute accuracy. Yes. Okay. Okay. No. Reference model, locate reference model. I only got the one part in there. Again, we went through the process. You can change the layout to visually see. Well, that kind of got messed up. Oh, because I didn't actually bring it in properly. Sorry. Again, want to orient it properly. I don't have it displayed, but I know I've got a mold coordinate system. So again, you can easily go and visually lay that out. Again, though, the power of the tool, not necessarily doing your splitting with all these cavities, because it'll cause you some headaches, but it's easier and better practice to do a single, because we just want to develop the parting lines and shutoffs, and then that information can easily be generated and extracted to use for the tool build, whether it's a single or multi-cavity tool, and or if it's a family tool. So we're gonna hit OK. Confirm. Workpiece, automatic workpiece. Again, we're dealing in metric. So I've generated my workpiece, my box around this part. We'll leave the dimensions. You can modify that however you want. Silhouette curve. Loop selection. So this bypass, I know that this is not going to work properly. I'll tell you what, let's go through the process real quick. Parting surface, skirt surface, select the curves, done select. Does not like that preview, okay. So it gives you the warning if you go through the process, they'll tell you certain curves cannot be utilized properly. So we're gonna hit okay, or hit cancel. I know that this is going to fail. Exit out of here. We're gonna redefine the silhouette curves, loop selections. I can window select that curve and select exclude. Now I know that these other curves look fine. Select OK. Parting surface. Select curve. Select the curves, done select. We want to check again the extensions. We can check a preview. Nothing shows up in the preview. That kind of indicates we have to go to the extensions. Extensions, add. So again, as we mentioned on the other one, we've got to make sure that the geometry, we've got one arrow, and they're hopefully pointing in the same direction. So what we want to do here is we've got some conflicts. Select the reference side that we want to project to. It created the skirt surface for our separation of the core and cavity. It created a closed surface on this little boss we have, and then this bypass window here. We can select OK. Check. Parting surface. So now we're going to go through the process of doing a shutoff. In fact, here, let me cancel this. And let me change the display. And we can hide this. Go back into the mold. Parting surface, shut off. So we want to create a bypass window shut off. Shut off. So we want to select the surfaces for that bypass shut off. A couple different ways to do it. I'm still kind of old school. I'll just select them. There's not that many. Select them at once. So we selected the surfaces to represent our loop surfaces. Now we need to select the edge geometry. So we select the first edge, shift. Sorry, not shift, control. Oh, see, there's something I messed up, sorry. Details. I forgot to select that bottom surface there. So that created our bypass shutoff. Select OK. Back into the mold. We have to do our reference cutout. Mold volume split. Select our parting skirt surface and our bypass window. Select OK. Mold components. Cavity insert. We got our two volumes. I should have changed the names to core and cavity. We've got our representative core side. And our cavity side. And we've got our bypass shutoffs. Again, this can be streamlined or trimmed or cleaned up, but again, that didn't take too long. And now whether this tool is a multi-cavity, you've got core cavity inserts. You can easily design and develop this geometry within the Creo mold, a mold design extension. and either keep this internally or share it at whatever level, whether you're the product designer, simulations engineer, or a tool designer. Now, with that said, I probably kept everybody longer than we should have. We'll move back into the out of the demonstration and back into the presentation. And at this point, our next slide has our Q&A session. So, and we've got technical questions can be sent to myself and or any sales questions to sales@boundarysystems.com. We have our boundarysystems.com online, and we have a YouTube channel, which this video will be uploaded in the next couple of days. And there are a ton of other different webinars on there with different aspects of Creo Parametric and all of the other software partners that Boundary Systems works with. And there's even some molding design simulation webinars up there as well. So if that's okay, we'll just move on and open it to any questions. And I'll ask Shay if he needs to chime in or wants to move along with these questions and get these addressed as soon as possible. Sorry, we have a question. Can you utilize this to just create parting surfaces without creating the core and cavity blocks? Let's see. You should be able to. I have not tried to extract that silhouette surface, but probably I'd say split your blocks, and then you can easier to copy those specific surfaces, whether it's the core and cavity, and you've got all that other geometry, then you can copy and extract that. So I'd say yes, you can do without doing the blocks, but the extra less than a minute it took, I see more advantage of just creating the blocks and then sharing that geometry as well. Let's see. Not sure if there's any other questions.
Oh, I think, John, I see there's another question just came in. I think it's just a one-word question that says shrink. So maybe can you speak to how to incorporate shrink, or how the CMA handles shrink inside of the software?
Yeah, something that was very critical. That was actually one of the very first steps that should have actually been done. So let's see. Let's save this. Erase that. So let's start this over again. So we'll go through new process, manufacturing, mold cavity, and we're just going to do this. We're going to call it shrink for now. Options. I don't think I really have to do this again, but we'll just go through the process. Reference model, locate the model. Same reference. Done. Okay. So sincere apologies. We have bring in your reference model. You can do your workpiece, but your shrinkage right here. So the shrinkage, we can shrink by scale or shrink by dimension. Typically it's a scale. So yeah, can't believe I missed this. When you're dealing with plastics, whatever plastic material you have, there should be a recommended shrink rate that you'll receive from the material supplier or from the experience of the tool shop that's building that tool, especially if they've used that material before. So we select the shrink by scale, and we're going to the shrink rate, so 0.005, depending on your material and your coordinate system. So again, you can do this in different ways, depending on where you got it in the tool position or on the part. But so we're going to, in fact, I'm going to go to a higher shrink rate just to show the show it better in display. And you have to select a coordinate system that's in your part. So I'm going to select this. And here, as we hit preview, it wasn't much. That's why I changed the scale to a higher factor, but you saw it actually increase. So what we've done here, and then if we do hit check, so what you've done is it's added the shrink factor back into the parametric, the model tree of the part. And as you can see there, you know, working that is kind of going back with the same part, but you can see here that if I can suppress that feature, it goes back to what your dimension should be after it's molded. So yes, the shrink is an easy process. That took what, 4 or 5 steps to get that done. So hopefully that answers the question. And I can't see if there's any other questions.
Cool.
How do we incorporate?
Thanks, John. I think that answers the question. See, there's a couple other questions here that just came in, but we're sort of running out of time. We don't want to have a hour-long webinar video, so we'll go ahead and end the webinar right here. But for anyone else who asked a question that we did not answer right now on air, we will follow up with the person directly through email or by GoToMeeting as well, and make sure that whatever question they asked, we 100% address it. So we will not leave any question unaddressed. So again, if you didn't have your question answered right here, you can we will follow up with you by email. And again, just real quickly here, John will pull up the very last Q&A slide, and so John has his contact info on there. So if you have any questions about mold design, mold analysis, or any technical questions whatsoever, you can jot down his email and then shoot him a quick email. That being said, thank you so much for joining this version of Boundaries Webinar Wednesdays. Stay tuned for the next Wednesday when we show a different topic, and you can always go to our website and see the list of webinars we have planned out, and sign up in advance for any of those webinars. Thank you so much, and we'll see you on another version of Boundary Webinar Wednesdays. Thanks. Bye.
Thanks, everyone.